In science, we often need to deal with some very large numbers. For example, the mass of the sun. That is the mass of the sun. A 2 followed by 30 zeros in units of kilograms. That is 2,000 billion kilograms. There has got to be a better way to write that. Can you imagine if there wasn't? And so we find that the mass of the sun is 2,000,000,000,000. Yes, sorry, could you repeat that? I was with you up to 2,000,000. It was 2,000. So to represent large numbers easily, we use something called scientific notation. Scientific notation takes advantage of powers of 10. For example, 10 to the power of 2 means take two 10s and multiply them together. And you get 100. 10 to the power of 3 means multiply three 10s together. And you get 1,000. 10 to the power of 4, 10 to the power of 4 means take four 10s, multiply them together. And you get 10,000. So you should notice a pattern developing. When it's 10 to the power of 2, our final answer has a 1 followed by two zeros. When it's 10 to the power of 3, our final answer has a 1 followed by three zeros. 10 to the power of 4, again, four zeros. So if we wanted to represent the mass of the sun in scientific notation, we would need 30 zeros. So we represent that using 10 to the power of 30. This means we're multiplying 10 by itself 30 times, which gives us a 1 followed by 30 zeros. But the mass of the sun is actually twice that. It's 2 followed by 30 zeros. So we can multiply 2 by 10 to the 30 in units of kilograms, and that is the mass of the sun. It's a lot easier to write, and it takes up much less space on the page. The other problem is we have to deal with some very tiny numbers. For example, the mass of a proton is that is the mass of a proton. 0 point, and then there's 26 zeros, and then 1673 kilograms. A truly tiny number. So how do we deal with this? Well, again, it's using a similar trick. If we raise 10 to the power of minus 1, it means divide by 10, not multiply by 10. So this means divide by 10, which gives you 0.1. 10 to the power of minus 2 means divide by 10 twice, which gives us 0.01, a hundredth. 10 to the power of minus 3 means divide by 10 three times, or 0.001. So again, you see a pattern developing. The exponent here tells you the number of places to the right of the decimal that the 1 is. So in this case, 10 to the minus 2, the 1 is 2 places to the right of the decimal. Here, 10 to the minus 3, the 1 is 3 places to the right of the decimal. So in this case, I have a 1 that is actually 27 places to the right of the decimal. So I can write the mass of a proton as 1.673 times 10 to the minus 27 kilograms. And this 10 to the minus 27 has the function of putting this number, 1.673, 27 decimal places to the right of the decimal point. So as a challenge question to see if you've understood it, If the sun were made entirely of protons, how many protons would there be in the sun?